The opposite.
The one that is most likely to do what?
Oxidize.
Oxidize, which means what? Lose electrons, right? So which ones do you think you can safely eliminate? That will not even be a potential answer on number one.
And then a 4 minus.
What'd you say?
The elements in MnO4 minus.
Well, which elements? Like sodium or the sodium ion? Because there's a big
Sodium.
difference between the two.
Sodium.
So you don't think sodium would be willing to give up an electron and turn into Na+.
Yeah, it loves
Oh, yes, it would.
it. It loves it.
Yeah, it would.
It just can't get enough of those mild. Actually, it hates the electron.
You can't mine sodium.
So right away, could a hydronium ion, H+, be a good reducing agent?
It could be A. Not very
It
good.
can be anything you want it to
It's
be.
like the most average reducing agent.
Okay, think about this. Okay, just think about this for just a second.
Fine,
Bye.
Yeah, I have to go to BPA. I'm gonna swim into it.
Go win.
Okay,
Max for us.
whoa. Let me give you the assignment.
Okay.
No.
Go win state,
There.
or else I'll be disappointed.
You got this, Anna.
Go.
Nobody else is smart.
Seriously, how did I lose my?
See, that's how I am. Literally, like,
I don't have a
Just
certain number
because
of places I
just
can
because
put it.
Burkamp loses things doesn't make it okay.
Okay.
Take Burkamp, but turn it as homework on time.
So could H+ be a reducing agent?
No, it could be minus.
no.
No.
No, why?
H2.
It only has the one electron.
It only has one electron to begin with, and guess what?
It's gone.
It's gone. It has no electrons to lose. Okay, H+.
YOLO.
Yes, it's a borrowed one. Okay, it doesn't even have an electron to lose. It's not there. Okay, so what do you have as your answer for number one then?
So,
Sodium, D, right? Not the sodium ion, not Na+, but elemental sodium, because there's a huge difference between the two. Now, what about on number two? By definition, this species is defined as 0.
It's B.
H+.
H+, very strong oxidizing agent.
A.
A, MnO4, because again, you're going to have this chart, okay? So you're going to find, if you want a good oxidizing agent, which is code for something that's very willing to reduce, you're going to look somewhere towards the top of this, on the reactant side of a reduction chart. And the highest one up there is MnO4. The cation that can oxidize magnesium. Now, so you have to understand the code. If something's going to oxidize magnesium, what are you going to make magnesium do?
Gain an electron.
Make it lose
Lose
You're
electron.
going to make it lose an electron. Okay? You're going to make it lose an electron. So the question is, which of those elements can take away an electron from magnesium? Now, would Na+, okay, let's talk about sodium. Is there a chance that Na, if you react that with magnesium, that it would form Na1 minus and Mg2 plus?
Probably not.
No, okay?
Probably not.
No. Categorically, no. Stop. Okay, you're not going to take two metals and turn one into an anion and the other one into a cation.
Could happen.
Okay? So basically, you're going to look for the ones that are most willing to take an electron, which leaves you with what on number 4? Hydronium, B. Okay? Because H+, and again, this, if you have a visual, oh, I drop a strip of magnesium into hydrochloric acid. It dissolves and forms a hydrogen gas.
Sure does.
Use that as a model to say, okay, hey, where is magnesium in relation to the hydronium ion? You have to have a benchmark that you can use as a visual for some of these reactions. The elements that can reduce silver. Now, basically, by asking that, I'm saying which elements can give up electrons to form Ag+, to take Ag+ and turning into elemental silver. There's two answers. What do you have?
H2 and sodium.
H2 and
Sodium.
sodium. So
The
you have
only
C
two
and D.
elements on the list.
Okay? All right, so if you go down, so let's talk about number 6. What's your answer for number 6, Jason?
I don't think you'll like it. C.
Yes, beautiful.
Yeah.
He did like it.
I did like it.
C is always the answer.
Miss Woodruff, what do you have for number 7?
Well, I had C, so it's probably not that.
Oh, it is.
Oh,
You're good.
oh, sweet, cool.
Miss Stone, what do you have for number 8?
Oh, D,
Huh?
D,
D?
uh-huh.
Thanks for playing. No.
What?
Is it below or above? I mean, is it to the left or right of D?
It's probably to the left.
No.
To the right.
It's to the right.
Yeah, E.
You should have referred to me, I had that right.
It's not a redox
I'm not
reaction.
cheating off you.
What?
It's
Wait,
not a
where you
redox
put it
reaction.
on the
It's
chart?
not cheating if you refer to me. It's only
It's
cheating
not a
if you copy.
redox reaction.
Only the hydrogen.
Oh my gosh, it's
not.
There's no electrons.
What about on number 9? Danae?
A. Nope.
Thanks for playing.
E.
Huh?
E. Nope.
Try
I'll just
B.
go through all of them.
It's a B?
What'd you say, Bruce?
B?
B it is.
Yeah! I don't know.
What?
Yeah, no, that's the way.
Would you like to walk through that one?
What?
Well, look, just start with this. You have elemental chromium turning into Cr3+. So right away, that has 3 electrons that it's lost. So right away, I know whatever my answer is has to be a multiple of 3.
There's only one of those on
And there's only one of them on there.
there. And
Okay.
it's 3.
That's
Yeah.
And MnO4 minus is also 3 electrons.
Okay.
It's true.
Anyway,
Yeah, T.
so what do you have on number 11?
11?
C. 10.
What about 10?
Oh, 10. What do you have on 10?
C.
10 is C. On 11 you have.
B.
On 12 you have.
C.
On 13 you
Hold on,
have.
hold on, hold on. Yeah, wait, wait.
C.
12 is C.
Yeah.
Yeah!
C is
I got
always
ahead of
right.
myself. 13 is
C.
C. 14 is
A.
now is A. Now would 14 be a spontaneous reaction?
No.
No. 15 is going to be
D.
now 16. Which element is the cathode and also the reduction?
Nickel.
Nickel. That's cool. Now on your overall balanced net ionic equation, this is what you should have: 2Al plus 3Ni2 plus yielding 2Al3 plus 3Ni.
Yay.
Yeah.
Okay?
Yeah.
E naught is going to be
1.89.
1.43. Okay, or it could be 1.41 depending upon which chart you looked off of. Now, here's what you have to watch for on that calculation using the Nernst equation. So you're going to have 1.41 minus 0.0592 over times the log of, now, what you have to watch is that you've got to square and cube
Yeah, I did that.
because of the coefficients. You have to square and cube those. Okay?
That's so big brain.
Because your aluminum ion concentration is there, your nickel concentration is cubed.
1.47.
1.47.
1.47, 1.45,
Yeah, Jason.
depending upon what you got. Now, what would have happened if the value of these polarities had been reversed?
Go down.
Go down.
It would go down because now you're taking the log of the Q value that's bigger than 1. Okay, we're good.
Yeah.
Do you want us to just hold on to these?
Yeah.
15, I can live with
So,
that.
like this whole section.
And this is Kim and Mount. I would say I need to be better.
I didn't get this whole section.